When working on residential electrical service panels, safety should always be the top priority. There are several recommended methods to ensure a safe working environment. One highly recommended method is to use a temporary disconnect switch. Installing a temporary disconnect switch before the service panel provides a safe and convenient way to isolate the panel for maintenance. This allows you to work on the panel without the risk of electrical shock from the main power source. If you are not comfortable working with live electricity, it is always best to hire a qualified electrician to assist you. A qualified electrician has the knowledge, skills, and experience to safely disconnect the power and perform the necessary tasks. They can identify potential hazards and take the appropriate precautions to protect themselves and others. For small tasks, there are some acceptable methods that can be used with caution. Shutting off the main circuit breaker isolates all circuits in the service panel, but it is important to remember that the panel is still energized from the lugs. Therefore, exercise caution and avoid touching any metal parts. Another acceptable method for small tasks is to cover exposed conductors. If you must work on energized circuits, cover all exposed conductors with electrical tape or insulated caps to prevent accidental contact. This will help to prevent accidental shorts and electrical shocks. It is also recommended to use personal protective equipment, or PPE, when working on electrical panels. Wear insulated gloves, safety glasses, and other appropriate PPE to minimize the risk of electrical shock. Insulated gloves will protect your hands from electrical current, and safety glasses will protect your eyes from sparks and debris. There are also methods that should be avoided when working on electrical service panels. Working hot, which means working on energized circuits, is the least safe method and should only be considered as a last resort. The risk of electrical shock is significantly higher when working on live circuits. Pulling the meter is another method that should be avoided. This is illegal and dangerous, as it can expose you to potentially fatal voltages. It can also damage the meter and disrupt service to your home. Having the power company pull the meter for small tasks is also generally unnecessary. This can be an inconvenience and expense for both the homeowner and the power company. It is important to always verify that the power is off before touching any electrical components. Use a non-contact voltage tester to ensure that the circuit is not live. A non-contact voltage tester can detect the presence of voltage without having to make direct contact with the circuit. Inform the homeowner of the maintenance you are performing and the hazards involved. This will help them to understand the risks and take precautions to protect themselves and their family. If you have any doubts about your safety, do not proceed with the task and seek professional help. It is always better to be safe than sorry when working with electricity. Here are some additional things to keep in mind. Firstly, always use the right tools for the job. Using the wrong tools can damage the electrical components and increase the risk of electrical shock. Secondly, never work on electrical panels in wet or damp conditions. Water is a good conductor of electricity, so working in wet conditions significantly increases the risk of electrical shock. Thirdly, if you are working on a circuit that is connected to a GFCI outlet, be sure to test the GFCI outlet before and after you work on the circuit. This will ensure that the GFCI outlet is working properly and will protect you from electrical shock. Fourthly, when working with wires, be sure to use the correct wire size and type. Using the wrong wire size or type can cause the circuit to overheat and create a fire hazard. Fifthly, always follow the National Electrical Code, or NEC, when working on electrical systems. The NEC is a set of standards that provide guidance on how to safely install and maintain electrical systems. Sixthly, if you are not sure how to do something, ask for help. There are many resources available to help you learn about electrical safety. You can take a class, read a book, or talk to a qualified electrician. Seventhly, take your time and be careful. Working on electrical systems can be dangerous, so it is important to take your time and be careful. Avoid distractions and focus on the task at hand. Eighthly, always double-check your work. Before you turn the power back on, double-check your work to make sure that everything is connected properly and that there are no loose wires. Ninthly, be aware of your surroundings. When working on electrical panels, be aware of your surroundings and avoid touching any metal objects that could be grounded. 10thly, keep a first aid kit nearby. In case of an electrical shock, it is important to have a first aid kit nearby. The first aid kit should include bandages, antiseptic wipes, and a cold pack. Also, it is important to know the location of the nearest emergency room. Remember that electricity can be dangerous, but by following these safety tips, you can minimize the risk of electrical shock. Consider that the temporary disconnect switch is like adding a master on/off button before your electrical panel. This gives you complete control. The qualified electrician can spot potential problems you might miss. They're trained to see things others don't. The main circuit breaker does cut power to most of your circuits, but those main wires coming in are still live. Be super careful around those. Covering those exposed wires is like putting a safety net around them. It's another layer of protection. Insulated gloves are your best friend when working with electricity. They're your first line of defense. Safety glasses protect your eyes from unexpected sparks or debris. It's a small thing that makes a big difference. Working hot is like walking a tightrope without a net. The risk is just too high. Pulling the meter can mess with your electrical system, and it's against the law in many places. It's just not worth it. Asking the power company to pull the meter for simple stuff is like using a sledgehammer to crack a nut. It's overkill. Using a voltage tester is like having a sixth sense for electricity. It tells you if something is live before you touch it. Informing the homeowner keeps everyone safe and on the same page. It's about respect and responsibility. If you're unsure about something, don't guess. Get help from a pro. The electricity is not something to mess around with. Always use tools that are designed for electrical work. They're made to be safe and effective. Water and electricity don't mix. Keep things dry to avoid accidents. GFCI outlets are there to protect you. Test them to make sure they're working. Using the right size wire prevents overheating and fires. It's a crucial detail. The National Electrical Code is your guide to safe electrical work. Follow it carefully. Taking a class or reading up on electrical safety is a smart move. Knowledge is power. Rushing leads to mistakes. Take your time and focus on what you're doing. Double checking your work ensures everything is right before you turn the power back on. Being aware of your surroundings helps you avoid accidental contact with live parts. A first aid kit can be a lifesaver in case of an electrical shock. Know where it is. Remember, respect electricity and stay safe. Let's delve into some specific scenarios and expand on these recommendations with additional context and detail. Imagine you're planning to install a new ceiling fan in a bedroom. The existing wiring is already in place, but you need to connect the fan to the circuit. Firstly, before you even think about touching any wires, locate the circuit breaker that controls the bedroom circuit. It's usually labeled, but if not, you might need to experiment by turning off breakers one by one until you find the right one. Secondly, once you've identified the correct breaker, turn it off completely. Don't just assume it's off, test it with the non-contact voltage tester. Hold the tester near the wires you'll be working with. If the tester lights up or beeps, the circuit is still live and you need to recheck the breaker. Thirdly, even with the breaker off, treat the wires as if they were still energized. Wear insulated gloves and safety glasses. Fourthly, carefully disconnect the old light fixture, noting the wire connections. Usually, you'll have a black wire, a white wire, and a bare copper or green wire. The black wire is the hot wire, the white wire is the neutral wire, and the bare copper or green wire is the ground wire. Fifthly, connect the new ceiling fan wires to the corresponding wires in the electrical box, using wire connectors. Make sure the connections are tight and secure. Sixthly, carefully tuck the wires back into the electrical box and mount the ceiling fan. Seventhly, before turning the breaker back on, double check all your connections and make sure everything is properly installed. Eighthly, once you're satisfied that everything is correct, turn the breaker back on and test the ceiling fan. In a more complex scenario, suppose you're adding a new 20 amp circuit to your service panel to power a new appliance in your kitchen. This requires more extensive work and carries a higher level of risk. Firstly, before you even consider this project, assess your skills and comfort level. If you are not experienced with electrical work, it's best to hire a qualified electrician. Secondly, if you decide to proceed, obtain the necessary permits from your local building department. This ensures that your work meets code requirements and is inspected for safety. Thirdly, turn off the main breaker in your service panel to de-energize the entire panel. This is crucial for your safety. Fourthly, using a voltage tester, verify that the panel is indeed de-energized before touching any components. Fifthly, carefully remove the cover of the service panel, exposing the circuit breakers and wiring. Sixthly, identify an available space in the panel for the new 20 amp breaker. Seventhly, install the new breaker, making sure it's properly seated in the panel. Eighthly, run a new 12-gauge wire from the new breaker to the location where you'll be installing the new outlet. Ninthly, connect the black wire to the breaker, the white wire to the neutral bus bar, and the bare copper wire to the ground bus bar. Tenthly, at the outlet location, connect the wires to the corresponding terminals on the outlet. 11thly, install the outlet in the electrical box and cover it with a faceplate. 12thly, before turning the main breaker back on, double check all your connections and make sure everything is properly installed. 13thly, once you're satisfied that everything is correct, turn the main breaker back on and test the new outlet with a circuit tester. In both of these scenarios, the key is to prioritize safety and follow proper procedures. Never take shortcuts or assume that you know what you're doing. If you're ever in doubt, consult with a qualified electrician. Let's elaborate on the importance of personal protective equipment. Insulated gloves are designed to protect you from electrical shock by providing a barrier between your hand and live wires. They are rated for different voltage levels, so be sure to use gloves that are appropriate for the voltage you'll be working with. Safety glasses protect your eyes from sparks, debris, and other hazards that can occur during electrical work. They should be ANSI rated to ensure they meet safety standards. Other types of PPE that may be necessary include arc flash suits, which protect you from the intense heat and energy of an arc flash, and insulated tools, which help prevent electrical shock when working on energized circuits. When working with electricity, it's also important to be aware of the potential hazards of arc flash. An arc flash is a sudden release of electrical energy that can cause serious burns, blindness, and even death. Arc flashes can occur when there is a short circuit or other fault in an electrical system. To minimize the risk of arc flash, always wear appropriate PPE, use insulated tools, and follow safe work practices. It's also important to have a clear understanding of the electrical system you're working on. This includes knowing the voltage levels, the circuit configurations, and the location of the main disconnect. If you're not familiar with the system, consult with a qualified electrician. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips and taking the necessary precautions, you can minimize the risk of electrical shock and other hazards. Consider NEC Table 310.15b16, which provides ampacity ratings for conductors based on their insulation type and insulation conditions. For example, a 12 AWG copper wire with THHN insulation installed in a conduit with no more than 3 current-carrying conductors has an ampacity of 30 amps at 30 degrees Celsius. However, if the same wire is installed in a hotter environment, its ampacity will be derated to account for the higher temperature. Always consult the NEC and other applicable codes and standards to ensure that your electrical work is safe and compliant. Furthermore, it's crucial to understand the difference between series and parallel circuits. In a series circuit, the components are connected in a single path, so the current is the same through all components. If one component fails, the entire circuit is broken. In a parallel circuit, the components are connected in multiple paths, so the current is divided among the paths. If one component fails, the other components continue to operate. Most household circuits are parallel circuits, which allows you to turn off one light without affecting the other lights in the house. It's also important to understand the concept of grounding. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor, which connects the grounding electrode to the service panel. All electrical equipment should be properly grounded to ensure safety. When working on electrical systems, it's also important to be aware of the potential for electromagnetic interference, or EMI. EMI can be caused by electrical equipment, such as motors, transformers, and computers, and can interfere with the operation of other electronic devices. To minimize EMI, use shielded cables, ground equipment properly, and separate sensitive equipment from sources of EMI. Let's also consider some common electrical problems and how to troubleshoot them. A trip circuit breaker is a common problem that can be caused by an overload, a short circuit, or a ground fault. To troubleshoot a trip breaker, first turn off all the loads in the circuit. Then reset the breaker. If the breaker trips again immediately, there is likely a short circuit or a ground fault. If the breaker stays on, gradually turn on the loads one by one until the breaker trips. This will help you to identify the load that is causing the problem. A flickering light can be caused by a loose connection, a faulty switch, or a problem with the wiring. To troubleshoot a flickering light, first check the bulb to make sure it's properly tightened. Then check the switch to make sure it's working properly. If the problem persists, there may be a loose connection or a problem with the wiring, which will require further investigation. An outlet that doesn't work can be caused by a tripped breaker, a loose connection, or a faulty outlet. To troubleshoot an outlet that doesn't work, first check the breaker to make sure it's not tripped. Then check the outlet to make sure it's properly connected. If the problem persists, the outlet may be faulty and need to be replaced. Remember, electrical work can be dangerous, so it's important to take the necessary precautions and follow safe work practices. If you're not comfortable working with electricity, it's best to hire a qualified electrician.